The Caterpillar 797B is one of the world's largest mining dump trucks. Despite weighing hundreds of tons when fully loaded, it is capable of moving enormous loads over steep mining terrain with remarkable reliability. In this animation, we'll follow the path of power from the engine all the way to the drive wheels, explaining how each component works together to move this giant machine. Let's look at some of the specs of this enormous truck. Imagine parking your family car next to a machine so large that the car barely reaches the middle of one of its tires. This isn't just a truck. Standing nearly 8 meters tall, the 797B is about as high as a 2-story building. Its overall length stretches to almost 15 meters, roughly the same as parking 3 large pickup trucks bumper to bumper. Now, look at its tires. Each tire stands around 4 meters tall, making it more than twice the height of the average adult. But size alone isn't what makes this truck extraordinary. Fully loaded, its total operating weight exceeds 620 tons, making it heavier than a fully loaded passenger aircraft. Moving such incredible weight requires an equally incredible engine. Hidden beneath the hood is a gigantic 24-cylinder diesel engine producing over 3,400 horsepower. Despite its enormous size, the truck doesn't rely on brute force alone. Every movement of the engine's power is carefully controlled through a sophisticated drivetrain, consisting of a hydraulic torque converter, multiple planetary gear transmissions, a heavy-duty differential, and planetary final drives located inside each wheel hub. Everything begins with the diesel engine. The Caterpillar 797B uses a massive V24 diesel engine capable of producing over 3,000 horsepower. The flywheel is directly connected to the torque converter. The first component after the engine is the torque converter. Unlike a manual clutch that mechanically connects the engine to the transmission, a torque converter transfers power using hydraulic fluid. Inside the torque converter are 3 main parts. The pump, also called the impeller, is directly connected to the engine flywheel. As the engine rotates, the pump throws transmission oil outward using centrifugal force. The moving oil strikes the turbine blades, causing the turbine to rotate. The turbine is connected to the transmission input shaft, meaning the engine can transfer power without direct mechanical contact. Between them sits the stator. Its job is to redirect the returning oil before it reaches the pump again. By redirecting the oil flow, the stator multiplies torque during vehicle launch. This torque multiplication allows the enormous truck to begin moving smoothly even when carrying hundreds of tons. The lock-on clutch directs this torque to the transmission. After leaving the torque converter, power enters the transmission. The transmission's job is to provide different gear ratios. Low gears multiply torque for starting and climbing, while higher gears reduce engine speed during faster travel. Instead of ordinary gears found in smaller vehicles, the 797B uses planetary gear sets. At the center is the sun gear. Around it rotates several planet gears. These planet gears are supported by the planet carrier. Surrounding everything is the internal ring gear. One of the greatest advantages of planetary gear systems is that different gear ratios can be produced simply by holding one member stationary while driving another. To move a vehicle from a dead stop, you need maximum power and low speed, which is the first gear, video. For this, the sun gear is the input or driven gear. The ring gear is locked to the transmission case using a brake clutch, and the planet carrier acts as the output. We shall look at the planetary gears in the next video. After leaving the transmission, power travels along the drive shaft into the differential. The drive shaft turns a small pinion gear which meshes with the large ring gear. This provides another reduction in speed while increasing torque. Inside the differential are spider gears. The spider gears allow each wheel to rotate at different speeds while still transmitting engine power. Power now travels through the axle shafts toward each wheel hub. These shafts transmit the enormous torque produced by the engine and transmission. The final stage of the drivetrain is located inside each wheel hub. Each wheel contains another planetary gear reduction. The axle shaft drives the sun gear. The planet gears rotate around the sun while meshing with the stationary ring gear. The planet carrier becomes the wheel output. This final reduction dramatically increases torque while reducing rotational speed. The result is enough pulling force to move one of the heaviest mining trucks ever built. Let's follow the complete path of power once more. The engine produces rotational power. The torque converter transfers and multiplies torque using hydraulic fluid. The transmission selects the required gear ratio using multiple planetary gear sets and hydraulic clutches. The differential distributes power to both drive wheels while allowing different wheel speeds during turns. Finally, the planetary final drives inside each wheel hub multiply torque one last time before delivering it to the tires.